Welcome back friends. In this video, I'm going to show you what bitwise operators are. This video may be longer than usual because bitwise operators can be a little tricky sometimes. Before moving on to the operators, I would like to show you what a binary system is. A numeric system that uses two digits, 0 and 1, is called as a binary system. Computers use binary system to store data and perform calculations. All data is represented by using 2 as its base. The way we represent numbers in units, tens, thousands, and so on, by the same logic, we will have the units place as 2 raised to 0, that is 1. Then 2 raised to 1, that is 2. 2 raised to 2, that's 4. 2 raised to 3, that's 8. So, the number 10 will be the addition of 2 raised to 3 and 2 raised to 1, that is 8 plus 2. And that's the reason it will be depicted as 1010. In this number system, 1 is true while 0 is false. And like other systems, this system has units. They are bits, bytes, kilobytes, megabytes, gigabytes, and so on. The conversions are 8 bits equal to 1 byte, 1024 bytes equal to 1 kilobyte, 1024 kilobytes equal to 1 megabyte, 1024 megabytes equal to 1 gigabyte, and they goes on and on. As you may have seen, these units are used as storage measurements in your phones, laptops, or any other device you use. Now, moving on to bitwise operators. These operators convert the input numbers into bits and do the operation on each bit. The syntaxes for the bitwise operators are ampersand, pipe, caret, tilde, and these two are the shifting operators. Now moving on to the ampersand operator. This operator is the bitwise for AND. What it actually does is it divides both the numbers into its bits, and just like the logical AND operator which gives the result true when both the conditions are matched, here the result comes out to be 1 only when both the numbers of the bits are equal to 1. I'll explain this to you with an example. So num1 equal to 8 and num2 equal to 9. So by what I showed you of number 10, number 8 will be 1 0 0 0 because all we need is 8, and 9 is 8 plus 1, so it will be 1 0 0 1. Now, as I told you, 1 is true and 0 is false. So for the result to come out true in ampersand, both of the numbers in the bit have to be true. Over here 1 is 0 and 1 is 1. So it's not going to be 1. Then both of them are false, that is 0 and 0, that's going to be 0. Then again 0 and 0, that's going to be 0. But over here it is 1 and 1, so that means the result is going to come out as 1. So the result is going to be 8, that is 1 0 0 0. Let me show this to you in Python. I have already opened a page and saved it. Now I'm going to use the same example, that is 8 and 9. You may ask the user to input the values, but for better understanding, I'm just showing you the same example which I have given in the presentation. So num1 is equal to 8, num2 is equal to 9, sol is equal to num1 ampersand num2. So print sol. Now you save it and run it. And as you see, the result comes out to be 8. I'll show you ampersand operators with another example. Okay, so now the numbers 8 and 7 are given. As I just told you, 8 is 1, 0, 0, 0. And 7 is the sum of 4 plus 2 plus 1. So it's going to be 0, 1, 1, 1. Now the result is going to be because ampersand needs both of them to be true, both of the numbers of that bit to be true. Over here, one's false and one is true, so it's going to be false. And all of them, as you can see here, one is false and one is true. The result is going to be 0. And I'll show this to you in Python again. Now, just in place of this 9, we can put a 7, save it and run it. As you see, result is 0. So I hope you understood what the ampersand operator is. Now moving on to the pipe operator. This operator is the bitwise for the OR operator. It means that it's like the logical OR operator, that either one of them is true, then it will print true, or if both of them are true, then the print will be true. So an example, I'm going to be using the same numbers to so that you can understand the examples easily. You can use any other number. Then 8 is 1000 and 9 is 1001. So as you can see, one is true and another one is false. So it's going to print true, that is 1. Then both of them in these two bits are false, so the result is going to be false. And over here both of them are true, so the result is going to be true. So result is equal to 9, that is 1001. I'll show this to you in Python. Pipe operators, num1 is equal to 8, num2 is equal to 9, all is equal to num1 pipe num2 print sol, and you run it. As you can see, result comes out to be 9. I'll show the second example over here. So 8 and 7 again. 8 is 1000, 7 is 0111, and that will give us a 0 against 1, or 0 with 1 in this bit. So 1 is false and 1 is true, so that will give us true. And as you can see, all of them here have 1 false and 1 true, so that will give us 1111, and that is 8 plus 4 plus 2 plus 1, that is equal to 15. Let me show this to you in Python. So just instead of this 9, put a 7 and run it. As you can see, the result is 15. Now moving on to the caret operator. This operator for bitwise operators is XOR. That means what it does is that it prints true when the true and false are not common in the same bit. So you can call it the opposite of AND. So using the same examples again, you can see that 1 and 0 is not true, is not common, and then the other 3 bits are common, so it's going to give the result to be 1. In Python, it's going to be the same thing. Num1 is equal to 8, num2 is equal to 9, sol is equal to num1 caret num2 print sol, and the result is 1. So I hope you understood what caret operators are. Second example. So here, as you can see, none of the bits are common to each other. That is, one is false and the other one is true, or one is 0 and the second one is 1. So that will give us 1 1 1 1, and the result is going to be equal to 15. And run it. As you can see, the result is 15. Now moving on to the tilde operator. This operator changes the sign of the number and reduces the value by 1. So changing the sign of the number, that means that if a number is a positive number, then it becomes negative, or if a number is negative, then it becomes positive. And reduces the value by 1, that is it subtracts the value by 1. Now an example. If num is equal to 5, then changing the sign will be -5, and then that will give you -5 -1. You will have to do for the tilde operator, and that will give you -6. I'll show this to you in Python. Okay, so num is equal to 5, sol is equal to tilde num print sol. Save it and run it, and the result is -6. So I hope you understood the tilde operators. Now moving on to the left shift operator. This operator converts the number into bits and moves the bits to the left by the number of digits you enter. So it's like the user's choice of how many times you want to move the bits. So let me show you an example. So 4 is 0 1 0 0. With 16 it's going to be 0 0 1 0 0. And now the user says num left shift by 2. So this 1 over here will shift twice to the left, and that will make it 1 0 0 0 0, and the result will come out to be 16. I'll show this to you in Python. Okay, so num is equal to 4 and sol is equal to num left shift by 2. Print sol. Now you run it. As you can see, the answer is 16. The result is 16. Now if you have understood this left shift operator, the right shift operator will be easy. It's basically just the other way around of left shift operator, and it moves the bits to the right of the uh, original position. So using the same example of number 4, you can see that from 4 it shifted twice to the right because it was the input given, and then it reached, and this one reached 1 over here. So that will be 0 0 0 0 1, and that is 1 in the binary system. Now going to the right shift operator, num is equal to 4, sol is equal to num right shift by 2. Print sol. Now you run it. As you can see, The result here is 1. Um, you may have noticed that the amount of time we take to solve these sums is almost like a minute or so, but Python solves it in just a matter of seconds. So you can see how convenient it is to be used. So I hope you understood what is the binary system and bitwise operators. In my next video, I will be showing you what are assignment operators. Thank you for watching.